Hi students, let us let us come to the topic number of half-lives of a radioactive substance after a time t. Okay, so that is, for example, let us consider at time t is equal to 0. Okay, at time t, that is at initial time. Okay, at time t is equal to 0, the number of atoms in that radioactive substance is 100. Okay, right. After some time, t is equal to, for example, say 10 seconds. Okay, after 10 seconds, what happens to this? The radioactive substance means it has to disintegrate, right? It disintegrates. Okay, disintegrates, and we'll say the number of atoms in that radioactive substance is 75. Right. Now, after t is equal to 20 seconds, okay, after t is equal to 20 seconds, actually what we can say, so here the 25 atoms disintegrate, so here also, so what happens, the number of atoms at after t is equal to 20 seconds is 50. Okay, but it is not right. Okay, what happens, it may be 60. Then after t is equal to 30 seconds, 50, it may, okay, it may be 50, and after t is equal to 40 seconds, it may be 45, and so on. That means not exactly, first it decreases or disintegrates from 100 to 75, means next also it disintegrates the same 25. Okay, the consideration is wrong. Why? Because when the number of atoms decreases, the disintegration also decreases. Okay, that means the activity also decreases, we can say, right? That means we can say that the number of atoms is directly proportional to the activity. Okay, number of atoms are decreasing means disintegration also decreases. So we can say, what is that? Number of atoms is directly proportional to the activity. See, number of atoms are decreasing, activity also decreases, right? So now n is proportional to a. So we'll come to the number of half-lives after some time t for a radioactive substance. Okay, so we know a is proportional to n, is it not? A is proportional to n, right? So we consider that at time t is equal to 0. Okay, that means at the initial time t is equal to 0, we can say that n is equal to n naught, right? Number of atoms present at initial time t is equal to n naught, is it not? So n is equal to n naught. Right, now for example, we'll consider the half-life period of this radioactive substance is t. Okay, half-life period is t. Half-life of the given radioactive substance, we can say that as t. Right, so now after one half-life, okay, after only one half-life, what happens? After one half-life means the time taken to disintegrate half of its quantity, is it not? The quantity is n naught, half of its quantity is what? N naught by 2. Okay, so we can write this as n naught into 1 by 2 whole power 1. We can write like this, na? Yes. Now, this is after one half-life. Okay, first half-life. First half-life. Right? After two half-lives, we can say after two half-lives, after two half-lives means first half-life is n naught by 2. That means second half-life is not, means what? Half of its quantity. Okay, first number of atoms n naught. So first half-life, half of its quantity n naught by 2. Second half-life, again half of its quantity, that is what? N naught by 2 by 2. Is it not? So we can write here n is equal to n naught by 4. So n naught by 2 by 2 can be written as n naught by 4, na? Okay, so I am writing like this. So what we get now, after two half-lives, n naught into, we can write like this now, 1 by 2 whole square. Okay, right. Now we'll come to after three half-lives. Okay, after 3 half-lives. Don't confuse that after 3 half-lives means this by 3. Half-life means half of its quantity only. Is it not? That means what? N naught by 4 is the present quantity. So, the next half-life means half of this quantity. No? That means what? By 2. What we get now is N naught by 8. Is it not? So now n is equal to n naught by 8, which can be written as n naught into 1 by 2 whole cube. Okay, we'll see one more half-life, right? After 4 half-lives. After 4 half-lives. What we get again? Remember, half-life means half of it time taken to disintegrate half of its quantity. That means now the quantity is n naught by 8. Half of the quantity means n naught by 8 divided by 2 only. Na? So n is equal to n naught. So see, n naught by 8 by 2 means what we get this as n naught by 16. So we can get n naught by 16, which can be written as n naught into 1 by 2 whole power 4. We can write like this. Na? So see, observe. After first half-life, n naught into 1 by 2 whole power 1. After second half-life, n naught into 1 by 2 square. After third half-life, n naught into 1 by 2 cube. After fourth half-life, n naught into 1 by 2 power 4. After fifth half-life, what we get? Obviously, n naught into 1 by 2 whole power 5. Is it not? We'll get the half-lives continuously. So, we can generalize this in the form that after n half-lives, we can generalize after n half-lives, what we get is n is equal to n naught. What we get, the generalization this only, now every time we are getting n naught into 1 by 2 after n half-lives. Is it not? After 1 half-life, power 1. After 2 half-lives, power 2. After 3 half-lives, power 3. After 4 half-lives, power 4. After n half-lives, power n. Okay, so after n half-lives, right, after n half-lives, the number of atoms present in the radioactive substance is, n means the number of atoms present in the radioactive substance only, right? So after n half-lives, the number of atoms present in the radioactive substance is nothing but n is equal to n naught into 1 by 2 whole power n. Okay, this expression shows the radioactivity of the substance continuously decreases with time. Okay, so that means what we can say, radioactive substance or radioactivity of a substance continuously decreases. Radioactivity of a substance continuously decreases with respect to time. Okay, time is increasing, the radioactivity substance disintegrates. Okay, disintegration depends like this. Okay, and after n half-lives, the number of atoms in the radioactive substance is n is equal to n naught into 1 by 2 whole power n. Right, here n is what? Number of atoms present at that particular time. Okay, number of atoms present at that particular time. N naught is what? Number of atoms present at initial time, where t is equal to 0. No disintegration takes place here. Okay, so n naught is very starting, number of atoms present at the initial time, that means t is equal to 0. And here small n represents what? Number of half-lives, 1 or 2 or 3 or 4, like that. Okay, so once again, n is the number of atoms present at the particular time. N naught is the number of atoms present at the initial time. This small n is number of half-lives. Okay, thank you.